So how do you build SDKs for, say, 5 different languages and make sure they don't slowly drift apart and become totally incompatible? Well, a company called Neuron has a pretty radical answer. Stop writing code. Seriously, instead you write specifications. We're going to dive into a system where the spec isn't just some dusty guide, it's the single source of truth that actually generates all the code.
All right, here's our game plan. First, we'll tackle the core problem, this SDK dilemma. Then, we'll get into Neuron's big idea, specs as code. After that, we'll look at their actual protocol stack, and I'll show you the secret sauce that makes it all click together. And finally, we'll talk about what this all means for building your own perfect SDK.
Okay, so first up, the SDK dilemma. You know, with all these AI coding assistants popping up, we're running into this new, kind of sneaky, and honestly pretty dangerous problem that's way more than just a simple bug. It's what's being called the hallucination problem.
Right now, developers are basically stuck between a rock and a hard place. You've got your traditional, handcrafted SDKs. Yeah, they're thorough, but they are painfully slow, they cost a fortune to maintain across different languages, and they always drift apart over time. Then, on the other side, you've got AI-generated SDKs. Super fast, right? But they have this one fatal flaw. They hallucinate. They just make up the architecture.
And there's this fantastic name for it: vibe coding. I love this term. It's when an AI spits out code that just feels right, you know? It compiles. It looks totally logical. But underneath, it's completely disconnected from what the protocol specification actually says. It is a silent, ticking time bomb in your application.
And here's the part that should really worry you. This problem actually gets worse as the AI gets smarter. A more advanced model doesn't necessarily give you more correct code. No, it gives you a more convincing hallucination. And that makes these deep architectural bugs almost impossible for a human developer to spot.
So how do you even begin to fight vibe coding? Well, the answer is you don't. You just change the entire game. And Neuron's approach is to treat the specifications themselves as the real source code. The blueprint is the product.
You know, this isn't some brand new crazy idea. It's literally how the internet was built. Think about it. TCP/IP, HTTP, TLS, the protocols that have lasted for decades, they survived because they were built spec first. Different teams all over the world could build clients and servers that worked together flawlessly, not because they shared code, but because they all followed the exact same blueprint.
And this image of the repository structure just says it all. The specs/directory, that is the core asset. That's the single source of truth. The imp/directory, the one with all the actual Go code in it, that's just a derivative. It's an artifact. The code is secondary. The spec is primary.
Now, this whole philosophy is locked in by the super rigid 6-phase pipeline. You start by specifying a feature, just in plain English. Then an AI comes in and clarifies any fuzzy parts. Only after that's done does it generate a plan, break it down into tasks, implement the code, and finally verify it. And get this, each stage is a quality gate. You literally cannot move on to the next step until the current one is absolutely perfect.
All right, let's zoom in on the system itself and see how this all comes together to build a complete, layered protocol for decentralized agents.
So the protocol is basically a stack of these individual specs, and they're built in a very strict order. It all starts at the very bottom, with spec 002, which is the crypto foundation. Then on top of that, you build identities. Then you add communication channels, then an on-chain registry so agents can find each other, then a system to prove they're still alive, and finally the on-chain contracts to glue it all together. The beautiful part is, each layer only ever depends on the ones below it.
Okay, so this brings up the million-dollar question, right? You've got all these moving parts, you're generating SDKs for Go, Rust, TypeScript, whatever. How do you absolutely guarantee that they can all talk to each other without a single misinterpretation? How do you stop that dreaded implementation drift?
Well, the answer starts with a really clear data flow. Keys from Spec 2 are used to create identities in Spec 1, which are then used to sign messages in Spec 4, and so on down the line. It's a nice, clean pipeline. But, you know, that's only part of the story. The real secret, the thing that governs them all, is something else.
And that brings us to the keystone of this entire system. It's a special layer that has one job and one job only: to enforce absolute, total consistency across every other part of the protocol. It is the one ring to rule them all.
Let's get really specific here.
how do you guarantee that a digital signature created in a Go SDK is byte-for-byte identical to one created in a Rust SDK, assuming they have the same key and the same message? Because any tiny difference, even 1 bit, would make them completely incompatible.
The answer is a single, incredibly powerful spec, number 006. So, spec 006 is totally unique because it doesn't have an API. You don't call it, you don't interact with it. Its sole purpose in life is to be the Constitution, the universal rulebook that dictates exactly what bytes have to look like on the wire, how they're encoded, and which crypto algorithms must be used, period.
And it pulls this off through 4 main pillars. It lays down super strict rules for the JSON wire format. It specifies the exact byte-level crypto algorithms, like RFC 6979 for deterministic signing. It provides what they call golden test vectors, basically a set of inputs and expected outputs that every single SDK has to match byte for byte. And it even unifies all the error codes so they're consistent everywhere.
And listen, this isn't just a friendly suggestion, it's enforced automatically. This slide shows a constitution check that happens way back in the planning phase. See Principle 10. Deterministic signing, it has a pass status. If the AI's plan had violated any of the rules from Spec 006, the entire process would have just halted right there, before a single line of code was ever written.
So, with this incredibly rigorous, spec-driven system in place, what does this actually mean for us, the developers who want to come in and use the protocol?
This really gets to the core of it. The real innovation here, the competitive advantage, isn't some fancy Go SDK or Rust SDK. It's the pipeline itself. It's the system that can reliably and repeatedly produce correct, interoperable code from a precise human-readable spec.
And this just lays it all out. The old way, you write a spec, then you manually implement it in every single language, and then you just cross your fingers and hope they all work together. It's slow, it's expensive, it's a nightmare. The Neuron way, you invest all that energy up front into one super precise spec, and from that you can generate and verify as many SDKs as you want automatically. It's a system that actually scales.
And that is the big takeaway here. The specifications themselves become the generator. And it makes you wonder, if a system like this can guarantee byte-perfect code from a human-written spec, are we witnessing the beginning of the end for the traditional coder, and maybe the rise of the developer as a pure architect of systems? It's something to think about.